Welcome back to the daily Leetcode challenge. Today we are ranked 951,000. Just crossed a million. Let's get right into it. It's day 12 of the streak. Alright, today's problem is 3405. Count the number of arrays with k matching adjacent elements. So we're given three integers. A good array of size n is defined as follows. Each element in the array is in the inclusive range 1 to m. Exactly k indices I. Exactly k indices I satisfy the condition the element before equals the current element. Return the number of good arrays that can be formed, and return it modulo 10 to the 9th plus 7. Interesting. So we're just given three integers, a good array of size n. Each element in the array is in the inclusive range 1 to m. Exactly k indices I. Oh, this looks difficult. I can see why this is a hard problem. It's like with this problem you don't even know really where to start. Let's just write down what we know. So, given n and k as integers, each element needs to be between 1 and m. I feel like there's a formula. Like you don't even need a loop. There's just a formula because this is like combinatronics or whatever. How many combinations can you form out of what we have or whatever? Exactly k indices I. Where I is just within the array. Exactly k indices exactly k elements are equal to each other. Adjacent elements. So with an array of 3, with the elements between 1 and 2, and one pair of matching elements. Oh, what is this? How do you calculate that, though? The first position has m choices. For each remaining indices between 0 and n, select k positions from left to right and select that for all other indices. Yep, combinatorics. Yeah, this is the problem where I'm not experienced enough yet to. This is wild because it has. When you see a hard problem, you know it has to be like at least O of n. So not only do you have to find just a brute force solution, you need to optimize it to make it O of n. So I really don't want to do this, but I don't think I'm solving this without the help. So I'm going to look at a solution and see how this works and why this works. Permutation and combination, yeah. Very large, array equals. Size will be n. As they mentioned, the answer can be very large. It means if you're thinking of recursion, just drop it. If you go with recursion, you simply try to create an array. Combination will be computed using math only. Yeah, no chance I was getting that. What are the possible ways to choose elements? Any element can go here, multiple permutations possible. 2. Solid wired permutation. '11th, 12th class given word. What? He says the Python solution is too slow. So is there? Oh, wait. Oh, I forgot the mod. TLE. Interesting. Where's the Python, my boy? Very slow. Yeah, so it's literally just a math and combinatorics problem. I think for this problem, it's good to see what other languages are doing. Alright, let's see the C++. I'm sure I can understand. Okay. Static inline long. It's a really long. Euclidean algorithm finds xyd such that ax plus by equals d. This is literally just a math problem. Define mod power to compute x by recursive method using binary expression. This is some wild stuff. This is absolutely insane. More of a math question than a computer science algorithm question. Maybe, I guess, Euclidean algorithm. Find the greatest common divisor of two positive integers. Number theory. 0 milliseconds. This one seems better. Wow. Const expression. The value of a variable or function can be evaluated at compile time. From runtime to compile time, improving performance and enabling certain optimizations.
Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is count the number of arrays with k matching adjacent elements. Now, the problem category is of hard level, but I would say you just need to understand the maths behind this problem, and this is going to
Super
be not
easy?
easy but super easy
What?
to solve. You just need to know about the maths of this problem. In this video, I am going to explain you everything which requires to understand the mathematics of this problem, and once you watch this video completely, this problem will be super easy for you. The given input in this problem is three integers. So we are given total three integers, and the integers are n, m and k. Let us say the integers are n, m and k. The output which we need to give in the problem is return the number of good arrays of size n. This n is given in the input. So we need to return the number of good arrays we can create of the given size n. Now we need to understand what is a good array, right? So a good array of size n is that array in which each element in the array is in the range of 1 to m. Now this is the first condition. If you want to create a good array of size n, then each element in the array will be in the range of 1 to m. This m is given in the input as well. So we need to create a good array of size n. A good array of size n will be that array in which each element is going to be in the range of 1 to m. This m is given in the input. The second point is exactly k indexes in the array will have this condition as true. The condition is ARR of I minus 1 will be equal to ARR of I. That is, for any given index, let's say the index is 1. At index 1, if the element is 5, then at index number 0, the element is going to be 5. Now this is one pair, or you can say this is valid for one index. So you need to have total k indexes for which ARR of I minus 1 will be equal to ARR of I. That is, adjacent elements in the array will be equal. So again, I'm going to tell you what is a good array. A good array is of size n when each element in the array is in the range of 1 to m. M is given in the input, and it will have total k indexes, or I would say total k number of places
This is what we know.
at which adjacent elements are equal. That is, ARR of I minus 1 will be equal to ARR of I. Now the answer can be too large. The answer is the number of arrays, the number of good arrays of size n. Now this output or the answer can be too large, so we need to return the answer, whatever the number of arrays we can create, mod 10 is to power 9 plus 7. This is what the question says. Now this k, m and n, all these three are given in the input, and now let us try to understand this particular question with an example. In the example, the given value of n is 4, so we need to create a good array of size 4. That is, it will have 4 elements.
Okay.
The indexes are going to be 0, 1, 2, 3. Total 4 elements, and these are the indexes. The given value of m is 2. It means all the elements in the good array is going to be in the range of 1, 2, 2.
Yeah.
This 2 is the m. It means all the elements in the array will be either 1 or 2. That's the range we have, right? And k is equal to 2. It means that we will have total 2 adjacent pairs in the array in which the elements are going to be equal. Or we can say there will be 2 indexes in the array for which ARR of I will be equal to ARR of
So
I
there's
minus
three
1. This
three
ARR is
elements
our array.
that are the
Now for
same
this given
next
set
to each
of input, the output is 6. It means we have total 6 number of good arrays of size n, and the elements in the array will be either 1 or 2 because the range is from 1 to m. M is 2, and there will be exactly 2 indexes, or I can say exactly 2 pairs of adjacent elements. Those are going to be equal. Now let us see what are those 6 good arrays. The indexes are going to be 0, 1, 2, 3. The array is going to be 1, 1, 1, then 2. This is the first array we have. Now let me try to prove that this is a good array. This is of size n, right? It has 4 elements, so it is the size of n array. Then we have elements as 1 or 2. That's the range we have from 1 to m, that is from 1 to 2. So the elements are 1 and 2. The next condition is there will be exactly 2 indexes for which ARR of I will be equal to ARR of I minus 1. Or I can say there will be exactly 2 number of adjacent paired elements. Those are going to be equal. So I can say the indexes are, for this first array, the indexes are 1 and 2. That's because for the index 1 and index 0, the elements are equal, right? 1 and 1.
Yes.
For index 2 and index 1, so if I say I is equal to 2, so I minus 1 will be equal to 1. So the indexes 2 and indexes 1, the elements are 1 and 1. So they are equal. Or I can say there is exactly 2 number of adjacent elements pair, those are equal. So this is the first pair we have. These are the 2 adjacent elements and they are equal. And this is the second pair we have. These are the adjacent elements and they are equal. So we have exactly 2 adjacent elements or 2 adjacent pair elements which are equal. In the second array,
get
this
the
is our second array.
intuition. I
We
get
are again
how
going
to
to have
like
4
make
elements.
pairs,
So n is
but
equal to 4 and the number of elements in the array is 4. 1, 2, 3, 4. The elements are 1 or 2, right? 1 or 2. That's the range we have. And there are exactly 2 pairs.
So, like,
this is
for,
the
like,
first pair of adjacent
very
elements
large
and this is the second
numbers,
pair
you
of
don't
adjacent
have-
elements which are equal.
you
In the third
obviously
array, this
need
is
a
the first
formula.
pair, this is the second pair. In the
Yeah,
fourth
that's-
array, this is the first
that's a
pair and this is the
good
second pair.
It's a
In
good
the fifth
array.
array, this is the first pair and this is the second pair.
Like
And in the
array.
sixth array, this is the first and this is the second pair. So these are the 6 number of good arrays we can
Oh.
create when the given set of input is 4, 2 and 2. The value of n, m and k. Now let us try to understand how can we
So
solve this
those are all
question
the
using
pairs.
purely mathematics. Now let me try to explain you one very important thing. We will come to this value of m, but first of all, we need to try to understand the second condition, which is for k indexes or for k adjacent elements, the elements are going to be equal. Whatever the value of k is given, let us forget about it. Let us just purely focus on what is the value of n. The value of n is 4. It means we are going to have exactly 4 elements in our array. And let us say the indexes are 0, 1, 2, 3. Now the question says that we want exactly 2 adjacent pairs to be equal. First of all, tell me, if the array is of length 4, how many adjacent pairs do you have? Is the number fixed? Do you exactly know how many adjacent pairs you will have? Yes. If we know the size of the array, if the size of the array is 4, that is n, then we will have exactly n minus 1 adjacent pairs. And let me show you how. If this is your array, if these are the indexes 0, 1, 2, 3, the size is 4, it means we are going to have exactly 3 number of adjacent pairs. This is the first, this is the second, and this is the third.
Okay.
And that is always going to be the case. That is, I can put a line here, and these two elements are going to be adjacent. I can put a line here, and these two elements are going to be adjacent. And I can put a line here, and these two elements are going to be adjacent. Or I can say they will form a pair. So I can say the total number of pairs I can form for a given value of n, that is the size of our array, is n minus 1. These are the total number of pairs we can create, and this will not be different, this will be same. So I will be talking about same pairs. Now the total number of same pairs, that is same valued pairs, should be k, right? The question says that we need exactly k number of pairs or k number of adjacent element pairs in which the elements will be same. That is, they will be 1 1 or 2 2 or 3 3, something like that. So again, let me tell you, if the given size of array is n, the number of pairs you can form, the number of adjacent element pairs you can form is n minus 1, and we need that total number of adjacent element pairs for which the elements need to be same are k. So there are total k positions, 1 2 3. We have three number of k positions, that is three number of places where I can say it forms a pair, 1 2 and 3, right? So there are total number of k positions to choose out of n minus 1 positions where the elements can be same. That is, if we have total n minus 1 positions to choose, 1 2 3 or whatever is the number based on the value of n, we have total number of adjacent pairs available are n minus 1, and we need to choose total number of k pairs, k adjacent pairs out of it in which the elements are going to be same. And that's what it's written here, that there are total k positions we need to choose out of n minus 1 positions where the elements can be same. This is the basic formula of combinations in mathematics. We need to choose k elements out of n minus 1 elements. So the formula is n minus 1 c k. N minus 1 is the total number of data we have. K is the total number of data we need to choose out of n minus 1. So the formula is of combinations from mathematics. N minus 1 c k. That's the formula we have. So now we can basically choose k number of positions out of n minus 1 positions, and we can keep the elements same. That is, the elements whatever we choose out of the range of 1 to m, we can choose to keep the elements same at these number of positions, right? Now let us try to understand the next thing. Now we need to put the elements, right? The elements which we have from the range of 1 to m. Now we have m different numbers from the range of 1 to m to create the array, right? We need to create the array, and we have total m different numbers to choose from. That's the range 1 to m, and we need to create our array. Now the first thing which you need to understand is, at the first position of your array, at the index number 0, at the first position, you do not have any restriction. You can choose any element which is within your range, 1 or 2. That's the range you have, right? If the value of m is 2, the number of elements you have is 1 and 2, right? That is total m number of elements. At the first position, you have no restriction because before the first position, you don't have any element. So at the first position, I can keep any of the element out of the m elements which we have. So I would say the number of elements we can have at the first position at ARR of 0, that's the first position, is m. So now our formula is m multiplied by n minus 1 ck. This n minus 1 ck is exactly what we have here. That is, how can we choose k different adjacent positions out of n minus 1 positions. Now we need to try to fill the element. At the first position, I will try to fill m different number of elements. Now what about the other positions? Now let us try to understand it. We have k adjacent elements that are same, right? That's the thing we know. And we have total number of adjacent elements as n minus 1. These are the total number of adjacent pairs we have, n minus 1 pairs. Out of this n minus 1 pairs, k adjacent pairs elements are going to be same, right? So the number of elements which remains is n minus 1 minus k. That's n minus k minus 1. Now these are the adjacent pair elements which will not be same. If you have not subscribed to the channel,
Alrighty. Peace.